Hey there guys, and welcome back. So, here on my desk I have a very special glittery box, which is probably going to tank the frame rate because, you know, bit rate rather, because YouTube limits bit rate. But regardless, uh, inside of this box, I have something very, very emotional to me. It is all the bolts that were inside of this multi-pack, which I knocked out onto the floor. Gosh darn it. Yeah, so I've been quite busy over the past several days working on the Dremel press. Right here. As you can see, basically assembled. And because I had the bolts out, using them, those ones specifically I was using for the back locking mechanism. That's what I was using for at the time. And they were on the desk and they got knocked off, and then I started crying. Now, most people would take an hour, clean up the bolts, sort them out, and be done with it. But I am going to do what we like to call a pro maker move here. And instead of spending an hour sorting bolts, I'm going to create a mechanism to help me sort the bolts. I'll still have to do it manually, but it will help me sort the bolts. And I'll spend the next 3 days doing that, and it's just what I do with my life at this point, I guess. So, here's the deal. Got our notepad. Also, composite board. So this is the, at least prototype-esque of the desk lit. I'm using it right now to just double check everything. This is slightly thicker than I would want it. It's about 5/16 I measured. I assume that may be nominal 3/4 inch composite board. Just a guess. But I was hoping for it to be more like 1/2 inch, but this is what I came across that I could get for free out of a pile, and is frankly nice enough. It does not look terrible. So anyway, test driving it now. Again, other desk lets that would sit up here would be theoretically lower down, but I can get the idea for, you know, what it covers and how it fits over in where I'm going to store it, etc, etc, etc. So that's why it's here now. And all that out of the way. So I've seen a few bolt designs before in the past, and generally how they work is you'll have basically a track, okay? And the bolt head sits up in here and dangles down like that. And that's basically how most of them work. There's another kind that I've seen that is a cyclone, okay? And both of these types vibrate. This one vibrates and the bolts basically walk their way up, and then they get stopped by little flaps, if I recall correctly. It's been a long time, but if I recall correctly, there's little flaps here that basically sort them like that. With this one, the bolt head, how this looks really is you have this offset ledge here, and then another ledge here. And so the bolt head, the bolt body is actually up against this wall, and the bolt head is like this. So the bolt can't get through. That's how it gets set up. And then the trick here is that they will put a hole here so that the bottom part here swings out, and then this ledge right here, because obviously the center of mass wants to go this way, that side of the bolt head slips past and goes out. And the height of this hole determines which bolt is coming out. And obviously you order it biggest to smallest. That way the biggest one falls out first, and the smallest one is still, you know, a smaller one. Let's say it's only this tall, wouldn't fall through the hole right here. So that's how they normally work. This is, frankly, I actually really do like this design. I think it's a pretty cool design. I have two problems with it. First off, and it's first one actually also applies to this design over here, the Cyclone version, is they require motors. Motors are A, loud, B, heavy, C, required to be plugged in. Honestly, it's not that big of a deal if I had a whole entire workshop, then I guess I could have it in the corner, and the motor just has to vibrate this. It doesn't have to be like a 4 horsepower motor, you know? It doesn't have to be that big, point being. But it is a consideration, and frankly, it's not something I want to do, so we will be going manual with this. The next problem I have with this design in particular, because let's face it, I'm not going to design this thing over here. This thing is industrial. This is an industrial design over here. And we're not going that far. The DIY option here, I always see these in like 1/4 to 1/2 inch increments on these slots. So, you know, one will be 2.5 inch, the next one will be 2 inch, the one after that will be 1.5 inches, etc. These bolts, I have, well, let me show you the case. 4mm, 5mm, 6mm, 8mm, etc. So my increments are not 1/4 inch, 1/2 inch, which would be like 6/12 millimeters. They are 1mm down here, 2mm when we get bigger, and then eventually 5mm, which is close to a 1/4 inch. But I am a bit skeptical that these holes will work as consistently if I literally have a 1mm difference between each of the holes. So that is why I'm not going this path. What I am thinking of doing, however, the idea with the tracks obviously makes sense. However, since we're not going to be having them drop out this way, the tracks will be parallel. I'm thinking that I'm going to make a grate. Okay, and this grate can be set up probably just because I have the 8mm rods. I might use 8mm. We'll see what it looks like in CAD. I may not. I may decide to go with bolts instead of rods, just because that may be easier. I also do have the 5mm rods, which would be more reasonable in size. However, again, those were technically dedicated to my project over here in the corner that's been sitting there for 5 million years, and I still haven't done, and you know. So technically those are taken, but you know. Regardless, I'm thinking that this is probably going to be like 5x5 is what I think is probably a good idea, a good size, okay? For 5 inches on each side square. About yay big, you know. I think that's a good portable size that I don't mind having around. This grate, the bolts will hang down like this, right? Well, you know, obviously spanning the grate. Okay, the grate, how you set that, one of those things, just 3D print, put the rods in after you put the 3D print in, so you can always take the rods out, put them in a different 3D print for a different size bolt. So I got M3s right here. The spacing will be for M3s. If I manage to drop another box of M4s or something like that, then at that point we can make up another grate for M4s. I'm hoping I don't drop a multi-pack of M4s or M5s. I don't really have a multi-pack of M5s. I have this guy, which has 3, 4, 5, 6, 2, 3, 4, 5, 6. So it's possible for me to drop this guy in theory. But these are also all individually bagged. So if I drop this, the bags are going to keep the bolts from getting mixed up. So that's probably not a concern, and probably this will only ever be for this one use ever. Knock on wood. Composite board counts as wood. So that's the plan. So the vibration, one of those things, it's a box this big. We'll take it, we'll shake it by hand. That's how we'll get all the bolts hanging down. The bolts, you know, will be like this, and we'll just shake it until they all fall into place, you know? Fall down like this. That's the idea. If we got to help them along, you know, give them a little push to get them there, that's what it takes. Again, that's the idea. So, once we have this, everything hanging down like this, my idea is to put it on a screw. Now, I'm not sure how many, whether or not it will be 2 screws or 1. And by screws, I'm thinking 3D printing these screws, okay? I'm not actually thinking of using real screws. But the grate can start out, you know, let's say 30 millimeters up. So this is the grate right here. And then we can twist these screws and just slowly lower the grate. And then as we lower the grate, the longer ones end up poking up. And then we can grab the longer ones. Again, as I said, this won't be purely automatic, but this is the idea I've got for the time being. Okay? So the bigger ones will be standing up above the other ones. That makes it really easy to see which ones are the same size. So we pull those out, and after we get them out, lower it a little bit, you know, lower it 1 millimeter, 2 millimeters, whatever it takes to get another batch standing up that will all be guaranteed to be the same size, because all the ones standing up. Here we go. I should draw that like that. So you can see how that works, right? The ones that are not standing up are obviously not on the floor, which means that they're not the same height as the ones on the floor. So that is the idea. Again, it's light enough. All this should be light enough that I might be able to get away with one screw. But if necessary, we'll, I guess, put some kind of mechanism in here to link these two screws. There's also the idea of possibly putting a sprocket in the middle with a screw knob and then bevel gearing it or something like that out to the sides. Like that. So it's turning both of these at the same time from the center. That's an idea. So that's what we're looking at tonight, to really quick sketch up and hopefully spend as little time as possible, because again, in the time that I've done this introduction, I probably could have a handful of these already sorted. So there we are. First off, let's see. I guess we'll start with the grate. New component. Grate. Does the grate make sense? I guess maybe I should do grate holder first, because again, the grate's going to be individual each and every single time for different size bolts. So grate holder, I think. Holder, there we go. And again, I'm saying 5 by, whoops, that is the wrong plane. I'm saying 5 by 5. The fact of the matter is that we can just say 5 by 5 is the inside dimensions. 5 inch. 5 inch. So the inside of this grate holder is 5 inches. And then obviously if we're going to be putting a grate down in here, we'll probably just put a lip on it. Is how we'll go about doing that. That did not work. There we go. So we'll toss a lip on here. One of these things, just a very simple 2 to 3 millimeter lip. Yeah. I guess we're probably not going to run into any issues with it on this design specifically, so I guess I'll use the offset. Offset can get kind of tricky sometimes because the contours break, but I don't see that being an issue this time, so we will go ahead and do this. Let's see. I should actually toss another offset around here as well. Let me click that dimension, please. Can I use that dimension? Huh. Fascinating. I guess you can't use the offset dimension. So anyway, I just wanted to do that so that I had that. And that should have been negative. There we go. So the other one is the lip. The inner one is the bottom, because obviously the grate needs to sit on something. So, and again, we're making a rather small design here, so I'm just going to stick to 3 millimeter walls. Doesn't need to be too hefty. Turn that sketch back on. Get this lip up again. Just going to go with 3 millimeters. From the, whoops, not that point. I want that face. And there, and join. So that is inside of that is where the grate will sit. Grate holder design. name. Great holder base. Great holder lip. And I guess really quick, I'll go ahead and toss these offset faces in for printing. I think I'm going to go ahead and go 0.2 because it doesn't actually need to be tight. It can be a bit loose. So, minus 0.2. There we go. And let's toss some color on there. Red. Feeling some red. Let's get actual red. Plastic matte. There we go. Alright, so again, grate sits in there. The grate doesn't have to be the same height. The grate can stick up. It doesn't actually matter. I believe. Yeah, no. It doesn't have to be the same height. The other thing actually is we could have the lip of the... No, we're good here. I take it back. Don't listen to me. Don't listen to me sneeze. 1 second. Alright, there we go. Bless me. Alright, so I do want to throw a funnel in here was my next thought. So the question is, how do we want to go about doing that? Actually, okay, you know what? I think we're gonna do this a little differently. Here's an idea. One of those things, instead of doing blah, 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 I can't talk, obviously. There's a million half ways to skin a cat, as I always say, and doing the same thing the same way every single time is not necessarily that interesting. So what I think I'm gonna do, and let's see, how big should the funnel be? I'm gonna say 50 millimeters. So we're gonna do this way. I think. We're gonna project this out. And I guess I project from the outermost. And we're gonna need this because of what we're doing to be a construction line. And if you caught on, good job. Yeah, you know what, we can offset. Nah, I don't like offset on this one. I'm going to do a rectangle, and we'll just center it up. Toss that. Toss that. Actually, I take that back. We already have this line over here, so I'll project that line out. There we go. And then I'll toss this way, that way I'm not overlapping. There we go. And have you figured out where I'm going with this yet? 5 inches plus, let's say, 2 inches. I should probably do it just that way. Let's just do it this way. 2 inches. We'll see how this looks. Alright, 2 inches. That's 2 millimeters. Inches. There we go. Alright, you ready? You ready? Figured out yet? I'm not going to label that yet until we actually do this. Loft. Loft is the answer today. And again, we're safe doing the first profile in multiple selections, but we can't do it with the top profile because Fusion doesn't like that. And one of those things, again, we can do something kind of funny like this if we want to. Make it a bit more interesting. Yeah, you know what? I think that's pretty interesting looking. Okay, and then the trick to this is we go with 3 millimeter walls, and we make sure to click through to the other side. There we go. Okie dokies. Actually. Nah, we can do it this way. Yeah, we'll do it this way. That's fine. So, now I can go ahead and label that, now that we have the secret unfolded. great holder. What did I just call this thing? Funnel. Funnel. Loft. Top. There we go. Top of great holder. Funnel. Yeah, just funnel. Alright. And now I can take this and we can go minus 3 millimeters is what I'm thinking. That should be a join. Join. There we go. And then this guy. Yeah, I believe that's how I wanted to do this. I think. Or do I have the wrong thing selected? What is selected here? I think. Okay, I can deselect that one, right? I'm just looking to select this guy is how I'm thinking this is going to be extruded now. This guy from the bottom here up 3 millimeters should be correct. Yeah, there we go. Looks correct to me. No, does not look correct to me. Oh, I see what I have to do. This should be 6 now at this point. This should be minus 6. Huh. Why are you going the full 6 millimeters? You're only supposed to go 3. Did my 6 millimeters not catch? Minus 6. There's that. Oh, I see. Actually, yeah, in that case, I was not thinking of this correctly. My bad. This is going to be here. This is going to be minus 3. And this is going to be cut. Now. And let's turn that off really quick to make sure. Yeah. Okay, that's what I wanted. That's exactly what I wanted. There we go. Just got myself a little bit backwards is all. Stop. There we go. And that offset is still accurate. That is not my offset. This is my offset. Yeah, that's a funny thing, right? Did it pull the loft back? It did pull the loft back. Alright, good. Good. Alright, there we go. And this does print a little funky. It's gonna print. I don't know which way is best to print it. Probably like this. So if I come back here and turn these back to just connected, right? I have no problem with that printing. I'm pretty sure that has, it's close to, well, let's check the angle really quick. Rather than me just say it's close to 45 degrees, we can actually just intersect, grab that, turn the body off. Buddy. Oh. You know, it's funny, intersect I think should do default to body. I don't actually think intersect should default to what do you call it? Profile. That doesn't really make sense to me. Okay, yeah. So 44.5. Like I said, close to 45 and 45 degree loft is just fine. When I do this, there we go. You see how that, so obviously down here is just fine, but as we get up to here, that is a bit scary. So let's do the same thing really quick. Take the intersect, and we are on body this time. And I'm going to take a tangent line if I can. I'll try to take a tangent line. I can't. Okay, so I'm going to just eyeball this up for, let's see, where is the most extreme? Maybe right there. Yeah, alright, you know what? I guess that doesn't look as bad right there as I thought it did. So, more like over here then. Try to not accidentally clip onto stuff. You know, auto connect. And that looks like that's more or less parallel. So how about this? This is, well, that says 35. Well, that would be 90 minus 35 is how that would work. So if that's 90 minus 35, that's 55. Yeah, 55 is not bad. 60 is where I draw the line. And I thought we were probably getting about 60 somewhere in this area, but maybe not. I mean, and now that I adjusted that, maybe we do. It's only 36. Alright, you know what? Probably print alright. Do I have Prusa Slicer set up over here on this user? Let's check. We do have Prusa Slicer set up over here on this user. And again, because this is Fusion, I unfortunately have to capture the whole desktop, so you get to see this boot up. Alright. Let's go ahead and see this. This is the first time I think I'm doing this live on stream. And drag this over here. And that was just my desktop. Obviously, you can see my desktop. It's not that big of a deal. Let's see. Desktop. Bolt Sorter version 1. Whoops. Where did Prusa Slicer go? There it is. There we go. Oh, that is big. Why is that so big? Print bed should be 8. Oh, print bed is 8 inches, but I'm starting at 5 and going 2 and 2 is 9. I was thinking it was 5 plus 2, but I forgot I had to add 2 for the other side. Let's scale this down really quick, just for the sake of arguments. And my scaling is linear, it looks like, so let's go 90% and see if that fits. Nope. 80, there we go. So, we hit the slice button, and look for our blue lines. Nope, it is happy with it. It's not showing any blue overhangs. So, yeah, we are clear, it looks like, with that. It's saying $3 for the funnel. Oy. Oy. That is an expensive funnel. And we scaled that down. Okay. This funnel is probably not going to be this big. That is $3 for a funnel I am not willing to spend the money on. Alright, this is getting downsized. So, not that one though. Hit Control Z a couple times. Okay. So this is coming down to 25. And this is getting shrunken up. So we're going to go... let's go 1 and see what happens. Wrong one. There we go. There we go. Hit the finish button. And since we have it, did I already close Prusa Slicer? I did already close Prusa Slicer, didn't I? Alright, whichever. One of those things. It should be significantly cheaper and faster to print at this point because we just seriously downsized a lot of it. So, the only question is back to this overhang right here. Screw it. We'll hop on over. Let me... Prusa Slicer. What I was going to say is, let me set up a Prusa Slicer scene here. Oh, whoops, my bad. I should have previewed. My bad. You get the black screen. There we go. You no longer have a black screen. And add a background. Where's my background at? There we go. Add background. That guy that I like. We'll drag you down so you're bottom aligned. Attempt to drag you down so you're bottom aligned. Oh, that is why. That explains it. There we go. Alright. And now let me resave this profile. Save mesh. Saved. Save. Replace. Window sounds. Desktop. Bolt sorter. There we go. So it fits the first time now. And let's look for the blue overhangs this time. No. Still says it's cool with this. Even at 0.3 millimeter. Alright. We did not actually save that much money though. We went from 313 to 270. So about 50, a little less than 50 cents. Let's see. I'm curious now. I am going to... Actually, if I suppress that, I don't think... Yeah, nothing works. Let's see. Split this body. That body on the origin should work. Oh, actually, I can just do that right in Prusa. Derp. I was doing that over on Fusion, but we could just split it here. That's right. Prusa has the ability to split. And this is 6 millimeters. And we hit the perform cut. And this is without the funnel. Alright, without the funnel, it's 44 cents. So that's $2.30. Well, $2.26 for the funnel. Which does not sound like a deal to me. Let's see. The funnel may be going. Because that is kind of expensive. Considering. We'll kick you back over to Fusion. Alright. The last option is to do a straight wall funnel. I mean, we do kind of need walls coming up to make sure while we're rattling this, they don't pop out. Which is why part of the reason why I had the funnel was to make sure that while we're shaking it to get all the bolts to align, we're keeping them from flying out. Yeah, I guess, again, $2.33 for this fancy stuff. Yeah. You know what? This is a YouTube channel. What we will do is, let's see. This is complete-ish right here, I think. Is that accurate? It can be, because I could make another component. So what I'm thinking is that this is one component by itself, and then the leveling system is a separate component. And because I have the flat edges right here, I can actually seat this into the leveling component, so you can swap this out if you need to. So yeah, we can step out right here. Go here, boundary fill, click, new component, and do not remove tools. Turn you off. This we'll call rename fancy grate holder, and that is just a regular grate holder. Kind of designed them backwards, but you know, okay. That again, we can just go on here as I was discussing earlier, because we extruded the bottom out by itself. Come down here to bodies, remove, and now we can hit the extrude button and go up 25 millimeters. 25 millimeters. There we go. So that's the basic straight box grate holder. Okay, I had an thought just now. The question is whether or not that thought is a serious problem or not. It kinda is. Okay. So, with it actually doesn't matter for this one. This one's actually just fine. Although we maybe want to make it a little bit taller. Nah, actually. No, we can still work around this. Okay. Yeah, we can still work around this. Okay, I'll explain it when we actually get there. let's get this finished off really quick. And this should also be great holder. Fancy great holder though. Fancy. There we go. Rename. Great holder modification or alternative. There we go. Rename. Removing fancy. Removing fancy body. Wall height. Great holder wall height. And do I have all these labeled correctly? Right there. Fancy great holder loft. There we go. And we should be good now. Okay. Now, just for the sake of... Okay. Because we went through all this trouble, let's kick you back over to Crucial Slicer. Slicer. There we go. I just wanted to label it. And we will go ahead and reload this from disk. Oh, we can't reload from disk. Okay. Reload from disk now. Control Z. There we go. Huh, that did not work. Let us grab the file then. 1 minute. Bolt. Is this the correct time? No. What did I just say that? Oh, I saved it as great holder. That is why. Okay. There we go. And let's see what this looks like now. Okay, $1.60. So 90 cents, or no, $1.10, $1.09 cheaper. $1.09 cheaper than the fancy one. Okay. Now, back to our previous discussion that I said I'd get back to in a minute. Fusion. Alright, now we need to do the grate, is actually what I'm going to do next. Again, the grate technically doesn't need to happen just yet, but to demonstrate the thing that I've been beating around the bush for, grate, copy that, hit OK. Let us actually come here, turn that on really quick, and get a top of grate lip. Top of great holder lip. Okay, and we will use that to start drawing. So where I stopped was if I extend, if I put the rods, actually, yeah, let me draw on this plane instead so I can, because that makes it a little bit easier to demonstrate. So let's take the intersect here and turn that off now. So if I put my rods here, and for the sake of the argument, we'll do 5mm rods, and then I need plastic holding those. So let's assume that we go 3/4 of the way. That way they kind of snap in. So I will go here and then do that divided by 4. Yeah, there we go. So there's that, and then we want this. That divided by 2 plus 3 for the base. There we go. And now I line this up here. There and there. So this was my problem, because this is my grate holder right here. Or this is my grate, rather. And as you can see, the grate, and I'll go ahead and even toss a little bit of a wall in here, just for demonstration purposes. That should not have gone like that. Just please go right angle, please. Fusion. Thank you. Stay. Whatever. Pretend this is a right angle. Okay. So that is gonna go. That's the wall of it. You know. That's gonna go there, and a bolt is going to end up in this slot right here. This was the problem that I was talking about. However, I said, oh, that is not going to be a problem. Actually, we can work around that, because what I'm looking at, or what I'm thinking about, is, and if I can delete these collinears, that would help. There we go. 3mm rolls. Control Z. Control Z. We're going to make this a right angle now because it's getting in my way. There we go. What we can do is actually collinear here. And we can collinear. Well, actually, I'll draw this one in first. I'm going to get there, but it makes our life easier to do this first. So, there, and there. Oh, did I accidentally... No, I didn't quickly did that. Control Z, Control Z, Control Z, Control Z. Come down. Why you know come down? Do I still have a... I don't have a... Why don't you want to come down, bro? Oh, there we go. That quinkydink right there is what's stopping me. Alright, anyway. One disaster averted for an example. So, we can do this. And that works. We can have this sitting down below here. So I was thinking that we'd run into a problem because it was sitting too high up, but we can actually just shrink the opening some. So now instead of having, zoom out here, get us centered. So instead of having all this space to work with, we're now going to have slightly less than this because, again, a wall thickness. So again, where that line is right there. So from here to there instead to work with for the bolts to hang down. And that's not that much. We're not losing out on that much. That's 3mm right there and 3mm right there. That's 6. 6 times 2 is half an inch on each overall. 1/4 inch on either side. So that's not a terrible amount of space that we're missing out on out of 5 inches. 1/4 inch out of 5 inches, not that big a deal. So I think it'll be alright. That being said, let's see. Is this actually... So I wasn't going to design it this direction, but I wonder if this actually is the correct direction to... Well, one of those things, again, 1.5 ways. But is this an easier way to design it? To do the rods. I was going to do a top-down, extrude the top-down first, and then put the rods in afterwards. But maybe I just do it this way since we're already here. So, great design. Oh, actually, I should call this... Yeah, I'm going to call this great because we actually don't want to put the rods in just yet. We want to... I'm just going to delete everything. What we want to do is copy this out and create templates for each size that we need. So 3mm, 4mm, etc. So we will start here with just an empty template, and then we'll go to let's see. Maybe not there, actually. Maybe I should do it the other way. Then we'll throw the rods in after we're done. Yeah, maybe do this. One of those things. Not sure what makes the most sense to... There's a couple different ways we can do this, and each one has different ways it can break, unfortunately. I don't particularly want to draw individual lines, is where I'm at right now. I kind of want to stick to squares. So I think I'm going to do it like this. And now we need to accommodate. I'll put one 5mm rod in here, again, just for reference point for the bottom, to make sure that we have enough space on the bottom. And that will be 3mm radius for walls. So this can go here so that we make sure that we have enough space on that wall. This, yeah, actually this again, I we can have this right here as that divided by 4. That makes sense. Okay, and that should be fine. And this is a construction line. Again, we're not extruding that just yet. At which point, this can go up to here, and the only question is do we want to, because right now I'm tangent here, but maybe instead we want to go coinkydink there to pick up a little bit of space. Because that is our closest corner. Because obviously this corner, this side and corner is further away. So that is our closest corner, so we should probably just coinkydink through that. Alright, there we go. And I will go ahead and... how do we want to... I probably don't. Yeah, I think we're going to do a sketch extrude to cut out the middle. I think that's where we're going with this. I don't think we want to shell this out like we did the other time. So I think that's where we're at right now. Turn the grate holder back on. Fancy grate holder. And we will two-sided object. And I believe that was heading this direction first. We can turn that off. And that is actually the wrong... see? Yeah. This is the one problem with doing it this way. Okay, this is what we're going to do. This is what we're going to do. We're going to take a step back. We're going to delete this guy. Wait, how are you no longer coinkydink? Okay, Fusion. Okay, never mind. I take it back. It's possible that I clicked, never mind, not that guy. It's possible that I clicked Control-Z too many times, and that's why that is. This instead will go here. No, we'll go tangent. That's right. That's how we're doing this. That will go there. And I guess I'll have to do this now. So what I'm thinking, in order to get around this, is we'll take a cut, a combined cut. Again, there are other ways to do this that were probably easier and didn't require me jumping through these hoops right here. But I did not opt to do that. Again, I could have drawn it from the top down and that would have been easier, but we did not. So we are taking the long way around. That is the wrong thing I wanted. A two-sided object. Two object. Turn this off. Is that the inside wall? That doesn't look like the inside wall. There we go. There. To object. There. And nah, yeah, I ran into the same problem. So, alright. I got too fancy for my own good. Rating Control-Z here. Keep on Z's, keep on zing, keep on zing, zing, zing. Sketch, there we go. Alright, we're going to do this the way I was going to do it originally. Project. I want that guy. Yes, that guy. And then, very simply, we can just extrude. Distance to object. And grab something around here. I thought I was going to be able to grab the corner. Hold on. If I do this, can I hit the adjacent faces? No, I can't. Okay. Let's just do 3 millimeters to save myself because, frankly, we spent too much time on this already. There's that. And come back here into the sketch. Draw the other one in. my other, what you call it, line, the other wall thickness. There's that. There's that one actually should have gone from here is what I meant to do. There we go. That, and center. And wall thickness, 3. And 3. We could have done offset like we did before. I did not, so there. Now we can do that. Actually, let's go ahead and modify this guy to add that in. I was going to actually extrude it separately, but it doesn't make any sense. There we go. And now we can drop that down. That. Yeah, so let's see. 5 millimeters divided by 4 is 1.25, right? So 1.2, well, we can do math. The computer can do our math for us. 5 divided by 1.25 plus 3, right? Yeah. And then we just need to make this. No. Jerk face. Okay, try that again. We need to make it minus, is what happened there, and for some reason it just erased everything I had instead of putting the parentheses in, but whatever. 5 divided by 4 plus 3 equals, there we go. That's what I wanted. That's what I wanted. And we hit join. Okay. Cool beans. Cool beans. We already have the offset on the inside, so we want to take the offset on this outside over here. This is great design. Great lip. Rename. Great walls. Okay. Turn that off. Get this offset. You need this guy still offset. Minus 0.2. Again, can be pretty thin, pretty loose rather in there. Not serving any practical purpose. And that is that for that insert. Right. Let's take a quick look at what we're dealing with. Throw some colors in here. So that was red originally. We will grab some yellow. Let's grab some yellow. Yellow. Plastic matte. There we go. Alright. So there's that. And we can section analysis. That's what I'm looking for. There we go. Section analysis. And there we go. So there is the grate sitting in there. And then we're going to put the leveling mechanism on the outside. Now, the leveling mechanism is going to fit just fine on this guy. I realized while we were working that it's not going to fit so much on this guy. So what we want to do is on this guy, take that, intersect this, and just toss a small rim around it to make sure that it, Control Z, we'll do offsets again, to make sure that it does not slide through all the way. So there's that, and then 3, and we're good. It's not gonna, that's not great for printing, but I'll cry about it. We could chamfer it, but oh, actually, yeah. So let us. What's the best way to draw this? I guess just like this. Yeah, I guess I'll just do this. That, and that. Toss some equals in here. Do, and call this. Yeah, 20 is fine. Okay. So, that at the very least, I hit the finish button already, right? Oh wait, did I control Z on the lip? I guess I hit control Z on the lip. So, what this is for is we actually don't need the whole entire ring, right? So we'll just do that, and it's significantly better on the supports. Significantly less support material. Cool. There we go. Make you red. Alright, and now it is time for the leveling mechanism. Just trying to minimize some stuff. Alright. New component. Leveler. And we gotta draw the ring in first. Where's my front? There we go. Do I want an intersect or a project? I guess an intersect will be fine. And I think I will take this guy, since his edges are more... no, I won't. I take it back. I'll go with this guy because it gives me less. It should just give me a square. Yep, just gave me a square. Alright, so that goes like that, because it is going around. And again, since we're using offsets in this design, I guess I'll use offsets. 3. There we go. This extrudes down. And this actually should only really go to the bottom of the grate, because we want to make sure that the grate, the grate itself, so the grate holder rather, we'll go to the bottom of the grate holder because we want to make sure that the grate itself bottoms out on the ground. Is the point. So long as we are at the grate holder, the grate extends below the grate holder, so it will always bottom out. In theory, I'm about to throw a mechanism in here, so that's going to take up some space. This may not be as simple as expected. Let's see. There are 2 solutions. The first one is to extend the leveling mechanism out further so that it can kind of sit beside the funnel without running into the funnel. The second option is to actually put a fake floor on the inside. That's the other option. That way we're guaranteed that the leveler is below the grate. I was thinking of not doing the fake floor because that's just extra plastic and we already have a desk that we can lower it down to. The other question is, how fancy do we really need to go with this? I guess is the other question. So is there an argument to... Pardon me. To just use screws, like actual screws? Nah, I don't like that. I don't like it. I take it back. It's too fiddly, in my opinion. Let's see. The only problem, really, that we're running into right now, I'm just going to go ahead and hit enter right now. Okay. The only problem I'm running into right now is linking the whole entire level system up. I guess we can put them on slides T-slots, dovetails, something like that on the opposite side, and hope that that keeps it from canting. Because let's go ahead back to the camera really quick just so I can demonstrate. If I'm jacking this side, whoops, I got my camera zoomed in really far today. If I'm jacking this side up with the screw, okay, so this is my plate, my grate rather. As you can see, this kind of wants to drop on this side, and actually with this angle it's kind of difficult to see, huh? I assumed extra far in because I figured that would make it easier to see the paper, but it's harder to demonstrate things. So as we jack up, obviously if this side's just hanging, it wants to droop, which is a problem when I have a 1mm difference between my bolts. So I kind of need to support both sides. At the same time, is this about 5 inches? It's a little longer than 5 inches. Yeah, that's more like 6. So imagine minus an inch right here, right? Problem is getting both of these screwed in sync without interfering with the grate, right? So if the grate is right here in the center, I can't just run gears through the center in order to do both sides at the same time, because in theory, back to the table, in theory the bolts are supposed to go straight onto the table, so we can't throw gears on the bottom. I guess we could do gears up and around is an option. I guess that's an option. The other option, I guess, maybe. So it just occurred to me. Rack and pinion? Which way would I do that? Maybe like this? So funnel. That there. And then here. Here. Rods coming out. Rods coming out this way, and then this way. Nah, I don't know. That seems overcomplicated. Might be a bad idea. Let's see. Here's a top-down view. My problem is that this area is all occupied. Right? In theory. So can't use that. I kind of wanted to put screws here and here. This is closer than doing corners, mathematically speaking, geometrically speaking. I don't think... actually, if I did corners, though, draw this in again. It's further away, but screw and screw, we're only going here as opposed to here and then here, which is different. So rod here, crankshaft here, not a crankshaft, but you know, shaft here, bevel gear, or worm gear, bevel gear or worm gear, and then same bevel gears on this side, so 2 bevel gears, and another gear right here meshing with both bevel gears. And that should work because we just have straight shafts here and here. Lifting up on this. Yeah, I'm not too concerned about it pivoting. because we're going to have plastic around these guys, and that's going to have a lot of contact area on the corner. Should be pretty stiff. Okay, I guess we can try that. Okay. Let's see what happens. Steam wants to restart for an update. That's what's what. Alright, so problem with this guy is clearing those corners. So if we want it to, because again, this is 20. I've got 30mm bolts, right? Which means that our screws have to be at least 30mm, unless I want to pick those out by hand. So I kind of want the screws to be like 30-40mm, which puts them up above this. Alright, let's see. Next question is bevel gear actually an option here? It is not. Okay, I've never actually done bevel gears, is the issue. So I don't know if I can grab zero. Let me start out with this spur gear and see if I can I was thinking draft is what I was thinking, but that doesn't actually make sense, right? So chamfer? We no, it's just the edge, yeah. So draft, we'll try draft again. My problem is I have so many faces. I can't do opposing faces, right? Yeah, I can't do opposing faces. Let's see what happens here. Yeah, that's my problem. My problem is that I can only select certain faces. No, that's not correct. Alright, time to Google. Again, have not done what do you call them before? Fusion bevel gear. Let us see. Okay, so okay, they do just have a what you call it, a plugin. Now there is a basic and an advanced, and I'm not sure what the difference is. I don't see. Let's see. Oh. I maximized the window. Oh my goodness, okay. Both of these cost good amounts of monies. Alright. So. Let us see. Looking at a tutorial really quick. Alright. Let me mute that. Muted. Skip ad. see. So, honestly, looking like it might be a little bit of work to get this done if I'm doing bevel gear. So, quick brainstorm. Do we have an alternative, or do I want to maybe do them off stream and let me Control Z really quick, do them off stream and go from there. Alternatives. Oh, excuse me. Was, let me check this really quick. No worm gears here. No worm gears either. Worm gear would have worked, but not an option. So let us see. Okay, the other option, actually, back to the rack and pinion. I don't have to drive both these at the same time. Okay. The problem with the rack and pinion, though, is I was thinking with a rack and pinion, it's easier to keep it level. My biggest problem is keeping them level. With a rack and pinion, you actually have an easier time keeping them level because you can see specifically how many teeth you have out. So you can just count the teeth as you roll down. With a screw, it's harder to keep track of exactly where you're at. Short of putting a what do you call it? A ruler on the side, a scale. A scale is the word I was looking for. But an indicator for how tall it is at the moment is the only option, in which case we could lift both of them up independently and then level it like that. There's also the option of actually putting a yeah. Alright, you know what? Let's do it independently. I think I will do it independently. And one of those things, there's a couple different ways you can handle this. One, you could put, again, a scale or something like that on the side to see where you're at. Or calipers, etc. Two is a level. You could get an actual level and just not care about how tall you are. One of those things, the screws that are sticking up will clearly be of different heights, so it doesn't necessarily matter that you know how much you've adjusted it up or down. So for that reason, because it doesn't necessarily matter, all that really matters is that you're level. And again, at that point, so I have one or two bags. I'm saying one or two because I think I might have two different size bags of bubble vials, bubble level vials, and they're super cheap. It's one of those things. I've used them in a couple different projects before. So for that reason, I think I will do this independently just because it simplifies the design so much and has significantly less chance for failure. So let's see. The top of this is fusion, or not fusion, Steam, get out of here. Stop interrupting my stream. Alright. This is, okay, it is at that, and that is the origin? Is that the origin? Pardon me a second, I got a cough for some reason. Where's my stream at? Alright, there we go. Just an issue through. Alright, Throat cleared. Yeah. So I think this is on the origin already. So I will come here, project out. Let's turn that off. Bodies. There we go. And then I also want to make sure I clear this big guy. So I'll project that out, and I'm, oh yeah, I turned it off. I was gonna say, what am I getting an error for? I'm going for project rather than intersect because I want the overall size here. So, and one of those things, again, this is gonna end up being larger than it should be, just because we have this fancy funnel here. If we didn't have this fancy funnel, I could put this screw hole right here. Well, these screw holes a lot closer in, but we can't. So there. Let's toss those in. Let's make this right angle to that. Let us grab the center line. There's that. Center that up. There we go. This is my offset. So let me give myself, well, it's one of those things. We're gonna put a knob on the top of the screw jack, the screw jack, to jack the thing up and down. So because we're going to do that, I guess I should probably give myself maybe 12. Maybe 12. So instead of whatever, and that is going to be like that. And that is equal to that. And that is equal to that. And did I? No, I didn't. Okay. There we go. And that should already be tangent. Yep, that is already tangent. Correct. Alright, so the last question is, how big do we make the screws? Yeah, let's start out at 25 and see what happens. I do want them kind of meaty, you know? Just one of those things makes it feel better, especially as a 3D print. So, that is that. We now need to throw the outline plastic on it and then connect it back to there. Right angle, right angle, right angle, right angle, and then we'll come back and put our tangents on. Tangents, 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 tangents. And I guess we'll see what happens with this. I'm not entirely sure I want to leave it at 3mm, but make that equal instead of copying my numbers over. There we go. Actually, do I want this at a right angle? It just looks kind of like it's probably fine. It's in all seriousness probably fine. I just, aesthetically speaking, it's just kind of ugly to me. So I'm thinking I'm actually going to do a bit of an angle. So let's go like, let's see. 60? Let's see how this looks at 60. And actually, just copy that. Again, this is just looks right here. Probably the plastic's fine being that thin, but for the looks. Okay, and let's extrude this stuff out now. Again, I might thicken that up around the screw. We'll see what happens. And yeah, I want to go to the bottom of the leveler. I don't want to go any further than that. We could go up though. We do have the option to actually go up as well. Yeah, and we should. We really should give ourselves more screw length. So let's grab this, and that is on top already. And let's go like, Let's see. So that down there is, I think, about 3, right? So let's go another 12 to get us up to 15 millimeters of screw capture force, etc. Alright, this is the leveler outline, or what do we call this? Cradle? I don't know. It's a cradle now. And, whoops, Control Z. Rename, thank you. Leveler screw jacks. Okay. And this is leveler cradle. Rename. Screw jacks. And screw jack support. Okay, and this is a leveler. And did I name Great over here? Nope, I did not. Great. And let's just double check our names really quick. This is correct. Yep, that's correct. Oh, that is Great holder lips, I guess. I'm not too great on the naming front, I gotta admit. Not too great at that. Alright, looks like everything else is correct. So let's go back in here and hit our screws. So. That too. And these are modeled and full length. So we're at the 25 millimeter and times 2. I forget, is that 2 millimeters per revolution? I totally forget what that is in metric. Obviously, it's not threads per inch, for the record. I was just trying to... I'm only asking because of how coarse it is, because one of those things, if I take it down to 1, it gets a lot finer, as you can see. Yeah, I think that's... well, let me do this really quick. Hit OK. And so I can... Oh, I guess that's not going to help me. Never mind. I just got to try measuring between 2, but obviously that did not work. Does it need to be that? It may not need to be that fine. I think I'm going to go to 2 and leave it coarse because, again, it is 3D printed. Now, with 3D printed screws, this can be a bit hairy. I recall a long time ago actually printing a whole bunch of them to try to figure out what was kind of the best offset for my printer. I had my Ender 3 at the problem at that point, and therefore my Ender 3 prints a little bit differently than this. So I kind of feel like 0.08 was what I was running on the Ender 3. I'm going to go 0.1, I think. That is 0.1. And let me just hit the delete button really quick. Control C just so I can Control V it back. I just want to see visually what the difference is. Normally, also for the record, I recall I found that it was these two as like one side and the inside didn't have to grab the bottom side as well. That was my experience at any rate. So there's, yeah, I think that's where we're gonna be at. Now, let me hop over here down to miscellaneous and try to find my bubble vial. What would that be called? Level? Did I have another level? Yeah, level vial. So I have an 8x35. Again, I don't recall whether or not that's the only one I have. The 8 millimeters is pretty thick compared to what we have going on here. Now, the only question is does that necessarily matter? So, if I come up here to, okay, so. Alright, it is a full 25 millimeter. something I was just thinking is I only have 2 points of balance here, and I don't particularly, I guess I could add feet. No, I don't really want to add feet. Well, you know what, if I add like a 3mm foot, that shouldn't be that big of a deal. Okay, that actually does bring up another good point. I'm gonna hop over here to great, because that's something I just realized. Let us go ahead and pretend like we were putting rods in here. Project. Look. Toss my circle in. This is a 5mm rod we were talking about, right? Come down here. This was 5 divided by 4. And now I've got a bolt here. I guess a square for the side of the bolt. So this is the bolt head here. And there is that. And you will call, this is my floor right here. So let's pretend that we have this bolt all the way down, and this bolt head is tangent to that because it's resting on that rod. So this right here is already 8.5 millimeters. That's a little bit of a problem. That is a little bit of a problem. Because my smallest bolts are 4 millimeters. And then I have 5 millimeters, and then I have 6 millimeters, then I have 8 millimeters. So all of those are going to be hanging at that point. And if I'm using a 5 millimeter rod, then my 5 millimeters and my 4 millimeters are never going to touch the ground, even if I take the rod and move the rod all the way down to the bottom here, which is an option. We can move the rod down because the rod is diameter of the rod is equal to or greater than those 4 and 5 millimeters lengths. So we have two options here. One, we can, instead of having this here again, as I stated, we can delete that, come down here, and do this, that divided by 4, and have it latched in like that. So even at that point, again, just for reference, the floor now is down here, because obviously the lowest we can get is this 5 millimeter rod. So this is the desk right here, and now from the bottom of this bolt cap to here, why can't I click that? That's my line, right? There we go, there we go, there we go. Yeah, so that's my 5 millimeters I was talking about, right? So option number 2 is we hop on the internet really quick and see what 3 millimeter bolts cost, because now putting it in the bottom, we are now at 3 millimeters, because again, it is 3 millimeter rod. Logic and physics prevail. So let's see what a 3 millimeter rod looks like, because I would have to buy that. 400 millimeters of 3 millimeter rod for oh, that's 5 pieces. Okay, so it's like $1 a rod. $1 a rod's not bad. One of those things I do have to spend a minimum of like $6, but don't have much of an option beyond that. Let's see. Brass rods are cheaper, which is nice. However, I don't know that I need 3 millimeter brass rods around, and I have to buy them in like packs of 10 or 20. So even though they're cheaper, it's not actually doing me any good. Do I need brass rods for anything? Do I want brass rods for anything? Because they're technically quote-unquote cheaper. I don't think so, but maybe I run into another situation. Yeah, see, this is the problem with being a maker is, yeah, DIY or whatever you want to call it, is that you're like, you know what? I can use the extra stuff for other projects. Yeah, totally. So. The 3mm rod is not that expensive, and I can't imagine having a bolt smaller than 3mm in length. So that would be fine. That would be the minimum size rod we would need, and again, it can snap into the bottom here. That's fine. So that solves that problem. We are going to go with 3mm rods instead of 5mm rods, which again is kind of okay because, quote unquote, those 5mm rods I have sitting around are already cleaned. Again, quote unquote. New component. Let's drill the screws in really quick. The second problem was just getting the vial into place, so I can drag it out a little bit, move it up a little bit. We probably can fit it in there. Yeah, let's go ahead and do that first, actually. Let's go ahead and do that first. So I'm going to go ahead and project out that guy. Not the body. I actually just want the face. Let me grab water really quick because my throat's getting scratchy again. Okay. And we need an 8mm vial. Look, I'm actually kind of curious. 1 second. While we're looking at stuff on the internet. Level vial. Is 8mm standard? Or, better question, is 8mm the smallest you kind of go? 5/16 is how many millimeters? 2 mm. Okay, I don't want to have to click on any links. Where's my fraction decimal chart? Fraction decimal chart. Click the picture. Check. So, 5/16 is about 8mm. Okay. So that's still 8mm. That's 5/16. Yeah, so I think 8mm is the smallest it's looking like at this point that the bubble vials go. I could be wrong. Could be just missing one. There's a 3/8 one. 3/8 is bigger than 5/16. That's logical. Okay. So yeah, this would be the smallest that we need to go, or that we can go rather. So I'm not making an excuse to buy a shorter or a smaller diameter vial. So there's my 8mm. And let's see. Let me intersect really quick for the sake of intersect that. For the sake of that, let me toss a 3mm piece of plastic around here. And let us see. I guess I could. Yeah. We can go tangent here like this. And then, actually I'll make that solid. If we go tangent down here, then yeah, there's, well, we do potentially run into that like that in that case. So if I untangent this, drag this out, give myself a little bit of breathing room, like a millimeter. Control Z, stop it. Stop. 1 millimeter. And then tangent that up there. Oh, I can't tangent that up there. Of course I can't. So round about there, I guess. So let's hit that and toss that tangent. Okay. And I guess I just call this 7.25 and we'll measure it out like that. Now, there's one of those things. Whoops, do not do that. I thought I hit E. I did not. Different ways to do this. So we could either put 2 holders and then hold it from either side. So, in other words, extrude out here and extrude out here and then slide through one side into the other side to hold the vial. That's one way. Or we can just run the length of the vial and snap it in. So, again, something like this. And only question is how exactly we want that oriented. Maybe just up and down. Maybe I'm just don't overcomplicate things. Go perpendicular to that, and then from there divide by 4. Nah, it's gonna have to be more than that. Divide by 3, or no, not divide by 3. That minus that divided by 3. Okay, that did not do what I wanted it to do. Okay. It's fine, it's fine, it's fine. So there, divided by 2 minus, no. What's the easiest way to write this? So my radius is that divided by 2. That divided by 2. That gets me to the edge. But I want maybe 3/5 of that. Or 2/5 of it. I kind of want 3/5 left off. So times 3 divided by 5. Yeah, I guess I want less than that even. So 4 divided by, or no, went the wrong direction. Yeah, what's 1 divided by 5? Grab this. 6 tenths. No. Okay, that's not what the way I was thinking of it. Never mind. I was just one of these things. Math on stream, I feel stupid for not thinking of this correctly, but math on stream tends to do it to me. So, we'll do that. We will do that. That is our plan. And symmetric extrude. And what did I say these vials were? 100? Were these 100 vials? Level of vial, level vial, level vial, level vial. 35s. I don't know where 100 came from. Oh, it's because I saw 1 inch, so the 1 was stuck in my mind, and it obviously wasn't 10. So, that's how I got to 100. Hold distance. And honestly, it doesn't even need to be 35. It could be sticking out either side if we wanted to. If we want to. Yeah, you know what? Save a little bit on plastic. And now looking at that, does that look like that's going to snap in correctly? Well, more importantly, does that look like that's going to print correctly? And it doesn't really, no. So, here's what I'm going to do. We're going to revise. This is going to go like, whoops, cancel, cancel, cancel. That is going to go like this and go perpendicular here. And I'm going to copy this off, delete that out, take that from the other side, attempt to take that from the other side, there we go, stop, there we go, there we go, there we go, and then what we can do, whoops, finish, hit this extrude, fix that. Alright, so now it snaps in from there, and we can toss a window in here. Best way to do this is, I think... Actually, no, we can still do that from that side. We can still do that from this side. And I clicked the wrong thing. Here we go. we can go like this, tangent this out, and then we'll just extrude, center extrude again. There's that. There's, actually that probably shouldn't be tangent there. Let's see. It's just a window, so I could... Can I do that? Can I get away with that? All I really want is a window. Yeah, in that case, if all I want is a window, then I can just say tangent, tangent. Tangent, tangent. Okay, never mind. There we go. Extrude. Toss that. Oh. Body. There we go. Symmetric extrude. Hole. 10. No, I did have to come in. Okay. So this right here can't be tangent. Delete. Oh no, not delete that. I thought I had the tangent there. There we go. But we'll do this instead. I'm gonna grab this and go like that. And go like that. And then let's see, toss this center line in here and go like that. And then the size of my window, actually I can probably tangent like this now. No, I can't. Really, I can't? Are you sure? Are you sure about that? Can't I? Why are you telling me I can't? No, I definitely can. Let me, maybe this is in the way? Fusion? Fusion. There we go. Yeah, I'll just leave it like this. That's fine. And one click profile. There we go. Oh. Finish. Come back here. Deselect that. And hit OK. And let me deselect the middle just for posterity's sake. There we go. Alright, there we go. Took me a hot second, but much better, and that will print. Okay. Groovy, groovy, groovy. Let's make this green. Not green. Let's grab one of my plastics. Let's see, we got red and yellow so far. Yeah, let's grab pink. Please. There we go. Oh, did I accidentally pick the other one? Is that what happened there? Up here. Turn that off. No, I guess I did not. I guess the pink just went somewhere else. Alright, so this is bubble vial holder. Cool. And that is rename vial holder. Holder. Okay. Rename. Window. Okay. Threads are self-explanatory. This offset, I believe, should be all the way back here. Right, there's an offset for my threads. It is. Alright, and almost done. Almost done. Again, the only real problem is going to be the feet on these things, on these screws. But I guess we'll see what happens. So this is screw. We can turn that off. And I guess we may as well just start from the origin. Project out the screw jacks and not the bodies. There we go. Okay. Where am I at? Where's my sketch at? Sketch, bolt sorter. Oh. Come back down here. Oh, and that's not even the correct place. Deleted. Hop in here. Create this new component. Screw. Create that sketch. Project out that profile. Okay. Extrude that profile. So, I guess it does not necessarily matter. Therefore, I am going to just symmetric extrude this at this. Actually, I mean, if I want to add joints in. If I want to add joints in, then it does matter a little bit. Just because the limits, setting the limits to the joints is easier if I have it at the bottom limit, is the only thing I'm thinking. Yeah, screw it, we'll do that. Okay. This screw from leveler, there we go. And then up. Let's see. I'm talking about like, well, to object, that. So this is all space that does not count, because none of this is being used. And then if I want actual lift past this, so if I want 40 millimeters of lift past this, then we add that as an offset. Okay. And we're going to change the color of that to purple. There we go. And now we toss the threads on there. Threads. Modeled. Okay. Toss that. That. Minus 0.08. Again, this is a guess at this point because it's been a while since I've done plastic screws. So, we'll see what happens. Now, the feet. Back to this wobbling a bit. As you can see, here is, I have this much space for feet right here, which, for the record, is that to that. So I have 1.25 millimeters in theory for the feet. The feet honestly should probably be like countersunk in here, is how they probably should be, and bolted on. I think that's how I'm going to do that. So let us control not control Z. I'm going to come back here, do a bottom of screw here, and I'm going to, I could just use the other profile. Okay, cool. So we got that far. This is bottom of screw. Bottom of screw. And I make the profile. And I project out. And this is what I was talking about when I was murmuring to myself just a second ago. I don't need to take that body. The problem with using that body is that the screw actually screws it up. So I want to use this sketch instead. And this is screw body. Screw body. This is going to be screw foot. Okay. And my plan here, turn that guy off, is, let's give ourselves like 4 just to be safe. And then the foot will come out much larger. And I hit X accidentally. There we go. So let's go out. Yeah, another 12 is fine. And I will extrude this now down, and then we'll extrude up separately. Distance to object, again, down to here. Okay. Turn the bodies on. And this is going to be a new component, I guess. I'll do the foot as a separate component. Screw foot. Rename, screw foot. And from there, what I'm doing is, let's see. I think we're just gonna press it in. Honestly, I think that's all I'm gonna do. So we will project out that again. That guy, and let's turn the body off really quick. That guy. Okay. I guess I don't need the second guy. I only really need this guy. And I was gonna flip this around, but I guess I just go minus 25, 10. Yeah, it really doesn't need that to be that deep. We'll do that. So that is the screw foot countersink. And then we'll hop back up here and combine these. We could cut it. Combining this more or less does the same thing for us. Cut, keep tools, okay, and then we're gonna go in and offset that. -0.1. We do want it a little snug. We don't really want it falling out. So there is that. So the foot just presses into there, and we're printing the foot separately because otherwise that becomes a bear to print. Because I plan on printing the handle here too. So we're going to put a handle on top, and I'm going to come back here and get a top of screw, plain. Come back down the end. Project out the original sketch, that way I don't have threads in the way. And we can turn the screw off for now, so there's that. And then toss this in here. So interesting story here. I started to program actually an add-in to do this, and then I decided that I don't do it often enough, and therefore I stopped. But it may be something that I might be interested in do for a stream. There. And again, because it's been a while since I've done it, I am kind of... So I know there were two different ways that I've done it. Which is going tangent here is the one, I believe. Tangent and tangent. And then one of those things. Actually, I'll declare the length of the screw instead, or length of the instead, knob instead. There we go. That's a word. Let's go like 12. And there we go. No. Huh. Why are you giving me angle? Everything is... That is... Oh, I see why. I see why. I grabbed the wrong thing. That makes sense. Alright, there we go. And we will make you a construction line because we don't need you right now. Oh, turn you off. There we go. Alright. So again, this is one way that I recall doing it. And for thickness, we're going to make it a little thick. We're going to make it like 6, let's say. And then we come in here with the fillets and start just making it look nice. Okay, for a second there, it looked like the screw somehow was coming through the knob. So we just fillet until it looks nice. And let's see, if this is 12, I'm going to go 6 here. And then we'll go 6 around the outside. Not all of them. I think it is 6. There we go. And that's a simple knob top. One of those things we can always, if we wanted to, just play with this more. So for example, we could back this up to something, and they don't have to match up. You don't have to add up to 12 necessarily. It's just how you want it to look. So if I call this 9 just to get it added up to 12, you see that. But I can keep on going, you know? Really depends how you want it to look, like I said. The other thing is, this did not have to be tangent, right? So we can come back here, delete, or no, I want to keep those ones. I want to get rid of tangents is what I wanted to do. We could shrink this up to like 12, let's say. Where's my tangent on that side? There it is. 12 is probably overkill. Maybe 20 would have been better. Or 18. Maybe 18. But the point being is that one of those things, so long as you compensate, everything should be fine. So that allows us, what that helps do is it allows us to get more of an rounding on the outside. You see how we have more space now to round like that, so we get more of a round profile there because we shrunk it up, because the edge is not as wide. So that's what that does. And again, I'm blanking on the other way. I recall there was one way that where I set it up, where I drew it out, where you actually, instead of flaying these guys in, you actually flaying them out rather. You actually flayed them in, and I can't remember which way I had that set up to work. But I think I will turn this back to the wider knob. No, I take it back. Control Y. What I'm going to actually do instead is change this to 20. Nah, I can't really be 20 because I can't really run into that. So 18. Let's top down. Alright. Gonna have to keep on shrinking because I can't run into the the funnel. Gonna have to dodge the funnel. Alright, 15 looks like it dodges. I just wanted more knob to actually grip onto, you know? And those are not equal at this point. There we go. Finish. And let's look at this guy really quick. Seven. Nah, too much. 5. Yeah, I'm gonna leave it like that. Could do 6. 6 probably will. Control Z. What about 4? Let's try 4 really quick. Yeah, I think I probably like that one best. Okay, there we go. So there's that. Let us go ahead and I have my this is as built now, right? Yes, that is as built. So that is rigid. This is as built joint. I literally just said I have that already, so I don't need that, right? Yeah. There we go. And this is the revolve and the cylindrical is what this is. And I forget how it's best to set this one up. Is it this one? Yeah, there we go. And now we can rigid group, no children. That, great and leveler. Okay. Come back out here. Turn the small one off. And let me attempt to grab that. Huh. Nice. Okay. It's funny because the animation worked correctly, right? Alright, whichever. I'll cry about it. Yeah, I'm not really seeing the screw animate. I don't think the screw's animating. I know that the revolve definitely isn't animating. Let's see. Did animate? Yeah, see, that works correctly. Drive joint. 10. 90. I don't need a separate motion link on here, right? Motion link. Link with same joint. Okay, maybe I do need a separate motion link. Nah, it's still not spinning. Actually it is. Yeah, I see the flipping back and forth now. The revolve flipping back and forth. So let me get in closer so that I am finer. Alright, you know what? We're playing around at this point. Cube. Alright. So, let me, really quick, create mirror components, screw, we are on the origin, so I can use the origin, and hit OK. I won't throw the other joints in. That's a little bit of a waste of time at the moment. We will, however, really quick lay out this grate really quick for our specific purposes. So I am going to hit the save button, derive the grate into a new object, and now you can go ahead and grab the inside wall there. Does that make sense? Maybe not. Maybe we grab the outside wall. Yeah, maybe that makes sense. Now, this is one of those things. I'm going to do this. That way I have a little bit of play. So it's going to be open on each side. That way we can, if we can cut the rods a little bit short, and they'll be able to not jam into anything. That's my idea at any rate. So let me also project the inside wall just so I know where I'm at. Okay. And actually I only need the one side. And this is a little bit of a problem that I did not foresee, but it's not going to be that big of a deal. So we decided these are 3mm rods. And this, I decided, is going to be that divided by 4. And that, I believe, should snap in at 1/4. Could be wrong, but we'll find out. So there's that. And then I am going to go ahead and extrude this out. Do I want to give myself a little bit of an edge right there? Probably not necessary. Probably not necessary. So, a little bit of clearance is actually what I meant. To object. There. There we go. And new component. I'm just going to do new component and then we'll join afterwards. Hop in here. And pattern along path. Bodies is what I want. Select that as the path. And spacing. And the distance is, set this back to 0. Distance is 3mm rod plus, let's say, so the heads are 5.5, right? The heads are 5.5. It's a 3mm, so we really probably want something like 4. 4 is probably fine. And I guess this is going to have to be a 1 then to go the opposite direction. And we will see how many of these fit in, because one of those things, it's not guaranteed to actually be the correct size. Now, one thing we can do is, let's see where we end up. Yeah, so that does not quite fit that last one. So what we can do is we can fill that in with plastic. Or, we know that this is 7 now, right? So I'm going to hit OK here. Come back up here. Hit this guy. We know it's 7. Let's see. What's the best way to go about this? We do not have 5 on the inside. So how much do we have on the inside? How are you? Oh, click the wrong profile again. 121. So 121 divided by 7. Calculator. 121 divided by 7 is 17 and a quarter. 17 times 7. 17 times 7 is 119. So I believe if I did my math right there, then 119 is the amount of space that we're taking up from one side of one rod to the opposite side of the end rod on the other side. So that's out to out of our 121. So that gives us 2 millimeters left over, which is 1 millimeter on each side. And therefore, instead of this being tangent, again, assuming that I did my math wrong. Yes, I said do my math wrong because I expect to do math wrong on stream at any rate. We will go ahead and toss a 1 millimeter buffer in on either side, and we'll extrude this across. And that will fill in the gaps. So that's on that side, and then we also want to put one on this side to fill this side in. And in just a moment, we will find out. I could put the math into these equations. That would be more intelligent. I am not an intelligent person, though, so we did not do that. Hold on. Alright, I'm going to hit finish here. And that does not look like that lined up correctly. Now let's check if this is 17. That is 17, which is what I got. That is my 1 millimeter across. So let me hit this and see where my math went wrong. Again, as expected. Not there. Tangent plane. Thank y'all. Tangent plane on that. Fusion, where complete, please. 180 from there. And tangent plane. Where are you at? You're upside down now. 90. Okay, and we will take the inspect between those two planes. So our out to out was actually 115. 119 minus 115 is 4 millimeters. Oh, bars and stars. My bad. So it was 7 times 16 plus, or no, it was 3 times 16 plus 4. No, backwards. 3 times 17 plus 4 times 16. That's the math that we needed to actually get the correct spacing here. So, anyway, point being, 15, so 21 minus 15. Hit Control Z a couple times. 21 minus... Actually, let's just put it in here, right? 121 minus 17 times 3, that's our number of rods, minus 16 times 4, that's the number of spaces we have, and we have 4 millimeters between each space, times 4. And then we divide that by 2 because we have 2 sides. We're splitting it up between the 2 sides. That was not correct. I put an error somewhere. This needs to be outside those parentheses. Actually, this needs to be outside these parentheses. I'm trying to zoom in on the equation. Obviously not working. Alright, let us simplify this some. That. That. And so there's that. That is 21 minus. That's divided by 2, and that's times 1. Let's clear these units out here so that we only have 1 units. And then we're times the 1 millimeter at the end. There we go. And that is still not correct. Let us see. Let us see. Oh. This is a plus sign in here because of my parentheses. Much better, much better. All right, all right. And then all you gotta do is be, oh, I do have that equal to that. Okay, finish. Extrude. Extrude. Where's my sketch at? That guy. No, not that guy. Turn you off. Not turn you off. This is the sketch I'm looking for. That. Oh, okay, that's not a close profile, that's why. Okay. We'll get there. We'll get there eventually. Let us intersect that. That will make my life easier. Right? I now have this line here. I do have this line here. It looks like. Yes, I do. Alright, cool. Finish. Extrude. These guys. These guys. Body. Distance. To object. To there. Join. Okay. Brosif. Broskowski. Are you not connected? You're not connected. I guess that would make sense. There we go. Extrude. Try that one more time. One more time. And celebrate. 2 objects. Join. Okay. That does. Oh, I see why. There we go. I was gonna say that does not look right. Now it looks right. Okay. Now. The final thing. Combined. There we go. I decided I don't want to click so much. So, we are going to pattern, features, that guy, not that guy. Turn that sketch off. I guess that guy. Oh, this is gonna be. Never mind. I'm clicking. I take it back because the way it patterns out may be really ridiculous. So, target body is that guy. Thank you. It may actually end up breaking if I pattern that out like that. So, I could pattern off the sketch. But I'm not going to spend any more time doing that. So, there we go. So. Go ahead and turn that off. That's what will be printed. It will be printed upside down like this, so that's no problem, right? That's an easy print. And again, so long as I got the 1/4 inch right here correct, or 1/4 diameter right here correct, then these rods should just snap in. Now, back to $5 or $1 per rod per 100 millimeter rod. We are at 126 millimeters. I forgot. This is a rather large. I forgot. We made this a full 5 inches. Right. So 150 millimeters rods is. Oh no, that's actually less than $1 a piece for a pack of 10 150 millimeters. So it is still reasonably expensive, and I have 17 rods. So this does actually get pretty expensive. So one of these things. At this point, I'm not going to do this on stream just because it's horribly unnecessary. But I think I'm going to shrink this down. The cost for these rods actually ends up being rather substantive, I'm realizing. Therefore, just, you know what, let's go ahead and, let's see, I already saved this. I'm going to save this really quick. We're going to go ahead and do the Prusa test really quick. This is bolt sorter M3. Great. There we go. So I'm not going to bother checking in Prusa slice of this guy. The grade itself, I'll just do the bolt sorter, and we'll assume that it costs slightly less because we're putting holes in it. It just makes things easier, it seems to me. Save as mesh. Okay. Okay. And let me get you swapped over to the Prusa slicer. Prusa slicer. Prusa slicer. There we go. And over here, delete all. Yes. Grab my desktop. Where's bolt sorter 2? Bolt sorter 2. No. No. Arrange. Let's see if we can fit it all on one plate. Alright, we can't, so I'm gonna have to do math, unfortunately. Alright, arrange. So, right now, flip this guy upside down. And we already decided that that print's okay there. Arrange. I should be able to fit the other screw over here, shouldn't I? Shouldn't you be able to fit right here? Arrange now. Huh. Why don't you think you can fit? Why you fighting me, Prusa? Why you fighting me? There. Alright, we're going to say that that is groovy. So, slice. Toolpath outside. Okay, so that's why you think so. And actually, is that this guy? Is that actually the... Alright, so this is going to go to, and we'll do even more math. Oh, and I didn't realize this guy was missing to begin with. Here we go. We're almost there. So, $1.80 minus 1. Let's click this, hit the P button, and then turn that back on. So the fancy one, we had the price for it, but I forgot already. I want to say it was $1.70. $2.70. $1 off. So that's $3, $4.50 minus 1. $4.50 minus 1. Leveler. Arrange. Doesn't say it can fit, but I think you can if I turn you this way. One of those things, again, I think we're shrinking this project down anyway, so it will fit, but for the moment, so we were at $4.50, so this is $5.62 minus 1 is $5.61. So we're at $5.61, and then it's $8 for rods, $9 for rods. Let's see. Yeah, $8.50 for rods, it looks like, for the 150 millimeter rods. So that is obviously more than the whole entire thing combined. Now, that being said, the way I did this, let's see, let's take a quick look. No, I did not leave myself enough space. What we can do is we can actually extrude this out further. That way we don't have to cut down rods. That is a good idea. So let's do that really quick. So this can go down. I am going to delete that to object. there. And then we will go down, let's say 5 millimeters. Okay, join. Hopefully nothing breaks here. Okay, nothing broke. The feet, honestly, I don't want the feet at this point. I did it to object because the feet were, you know, the most we could get out of at the time, but I don't want them more than 3 millimeters max. And that's on the other side, it looks like. So we're going to change this to distance 3 instead. Okay. Yeah, I don't want them being any thicker than 3 millimeters max. So that is that. Hit the save button. And now we hit the update button. And that should let me, whoops. Stop it. Let go. Shoot. I only imported the, actually, I should be able to do this, right? Yeah, I should be able to do this. So I'm going to go ahead and also grab, not that though. Let me hit escape and then retry that. I can also grab the leveler for reference. Everything else is above it. So there we go. So there's the leveler. So as you can see, these rods then can stick out this way. They'll be underneath the leveler, and therefore they won't run into anything. So we don't have to actually cut the rods down, which is nice. Oh my goodness. My bad. My bad, my bad, my bad. It's been, what are we at right now? 1 second. The stream has been going on for 2 hours and 20 minutes. And obviously it's getting too late for me because I forgot to swap you guys back over to Fusion. So, as you can see, what I was describing right there, and you used your imagination because you have a wonderful imagination, is I increased the depth of the, the grate. And then this followed suit, the feet followed suit because they were in line with the grate. Instead, I just minimized that down to 3 millimeters. And then I brought the leveler over to the sample grate just so that we can confirm that these rods right here, if we extend them, if we don't cut them out and we let them overhang, they won't run into anything. Well, it won't run into the edge of the leveler. It's the only thing that really matters because, again, the feet can go perpendicular to it like it is right here. So that is the deal. That's where we're at. Everything looks wonderful. Again, off stream, I'll go ahead and shrink this down a little bit. That way we don't have to spend so much money on rods. One of those things, when I shrink it down, then we will have fewer rods going this direction, and we will also be able to cut rods down at that point because, again, right now, buy them at 150, cut them down to 126. You know, that you can't even get 2 out of that, right? So if we shrink this down to, let's say, I'm trying to think of a good number. I mean, almost 75. I mean, if we shrunk it down, 75 is a good bit to shrink it down. Well, heck, you know what? Let's say 70. Let's say we shrink this down so that this ends up at 70 here, right? Then we pick up 150 millimeter rods, and we can cut those in half. So we need half as many rods because we're cutting them in half, and we need fewer rods to begin with because it won't be as wide. So that is the plan moving forward. One of those things, the little hiccups in the early part of the stream weren't that big of a deal, where I was like, let me do it this way. You know what, that's not really working out well. I didn't really mind those, but it really bothers me that I forgot to change the scene again. That does bother me, so unfortunately. Regardless, we are now done this, and it is important to mention that at 2 hours and 25 minutes in, the real question here is, in the time we spent designing this, could I have sorted out all these bolts? I'm not saying no, but I'm also not going to say yes because I don't feel like crying again. So, anyway, that was the stream. Thanks for hanging out with me, guys. I'll go ahead and, again, shrink this down, then get it printed out. And if you have been watching, thank you. And as always, I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world. And I will catch you next time.